Hi, welcome to another video on my Arduino Mega2560 and electronics. The topic is, as before, pulse width modulation. However, last time I encountered a few problems, and whether or not they have to do with pulse width modulation, I have to solve those problems. Well, this is of course the Arduino. I also have a few motors, and one of them is standing still. Now, considering the fact that everything is under power, there is a problem with a motor that is not running, because the question should be asked, why is it not running? And it just stopped last time and didn't start again. So what I can do is measure, and that is exactly what I'm going to do. So I'm measuring first the transistor that is with the running motor, and let me show the multimeter as well. So once again I'm probing on the transistor with the running motor, and you see it is 2.84 volts. Now I'm probing with the motor with the transistor with the motor that doesn't run, 4.6. Well, that difference can be explained by the number of transistors. However, since it has voltage over it, it should be running. And it stops now then because I moved the board and the wiring isn't too solid. But what I can do is to replacing this jump wire, yellow one, and I realize you can't see it, so let me turn the motor a bit, the blade. This yellow jump wire, I will replace it with this LED that was proven to be working. So first I will have to relocate this jump wire, and the only function of the jump wire is make the connection to the ground, so I can just move it one position to the left, and then adding this LED, which should be then right here, and it should light up if the cathode is completely straightened right now. So when I put it in, it should lighten up, which it doesn't do, and that's an oops. So once again, alright, I did have the correct direction. So then once again check, is there voltage over it? No, there isn't. There is hardly any voltage. Is there voltage on this side? None. Here? None. So how here is 4.6 volts. Once again here, none. So probably I need to replace this transistor. Let's see if that's true. So I've taken another transistor from my stock and I am putting it, oops, that's always a hard thing to do. Hopefully it will be exactly fitting. And then it should do something. So let's measure something again. And that doesn't do anything, so to a higher scale again. .7, and this one 2.87, and now it's going away. Okay, a little bit deeper. 4.7 again. Zero. This is 0. Let's measure the resistor. 2.40. And here is it measuring nothing. Measuring here, or more appropriate here, I'm measuring absolutely nothing. Here 4.8, and it's coming straight from the power. This one is 4.7. So something is not quite right, and if I measure from this line, because this is the root and I have to take care of this line, it comes to here. So how can something that is this volt and then coming here, which is again 0.06, here, again 0.03, and then I'm measuring at this transistor, and let me put the blade away so you can see what I do. .72. Now probing this LED, makes no sense. Makes absolutely no sense. Just like it makes no sense to do some simulation on this, because it used to work. And turning the LED the other way won't work. So right now I have this LED that is not working while it is tested fine, and this LED that is not working while it is tested fine. This one is without a transistor and that with a transistor. So, some riddles, and apparently this one is alright that I took out, but what's the cause? Without this, checking for pins 4 and 13 like last time, not really much use. Everything has to work. When I observe the circuit and measure everything, I notice that this part, this motor is fed by this transistor. Measuring it gives 4.80 volts, and a little gentle touch to this transistor makes the motor run. Without it, no such thing. Measuring, however, this is 0 volts or close. This is 4.8, and that is almost identical to this part. However, here is no resistor. So what I want to do is to remove this this inductor and put it put this resistor directly to this wire. See what happens. And it should not be necessary, because here I have a better view. Here I have several inductors in a row, and the motor is working very nicely. So why this is happening, I have no idea. Oh, by the way, I put the original transistor back in place, because if it would have been a transistor, it would have been solved, but no such thing. So, gently removing this inductor, and then relocating this resistor here. It should not matter. And it doesn't. It doesn't do a thing. While here everything just works fine, including this LED. And yet this is working. So should I then take it all off? No, because here are two resistors prior to this transistor, two resistors, three inductors and a transistor, all working nicely. One and one and one, not doing a thing anymore. This one doesn't even have a resistor, just a transistor, and it's working nicely. Is this a matter of pulse width modulation value? In theory that can be possible, of course, but I don't think so because it just stopped. The only thing I can do is go back to the program, make everything the same again and see what happens. And I think that is just what I'm going to do. Because this does not make any sense at all. So, as the electronics don't give a clue about how to restore everything working, I return to this part of the software. And okay, this should give 60 Hz, but 60 Hz without any reliable voltage. I'm going to do this, then getting back into function, this as well. So now this type of calculating, which was fake in the first place, has gone for now. Now everything will be 30 Hz. Let's see if this is anything. Yeah, well, let's put this back. Whatever. Let's put this back as well. Not quite sure what the difference will be. This will be a voltage, presumably. This will just be frequency. And I need 4 and 13. So let's give it a comment. And the comment will be just green grounded LED. Green grounded, green grounded LED, whichever. Uploading. Everything stops for a moment. Lo and behold, the non-functioning green LED is suddenly working, back in work. And let's touch, and the motor is working again. So it has, okay, let me do another test. I remove this. Let's see what that means. Alright, it doesn't do anything anymore except for the right side motor. It works. All motors work except for the motor that didn't work earlier. So I am putting back into action pin 4. The LED works and the motor works. So when I put this back into action, pin 13, and yes, that LED connected to pin 13 is working now. So apparently this needs to be working as well as this, and although this did work somehow, this is the real stuff. This is a very important conclusion. So pin 4 and 13 have to be measured again, but I guess they will be back at 30 Hertz. And that's a very big conclusion, but I can't say anything but that it is working again, and I'll show you on cam. This is unexpected to me. Both need to work, and it does. So, as you can see, two motors with propeller working nicely, two LEDs working very nicely, motor on the upper side working nicely, motor on the lower side with the switch working nicely, and most important, on the lower left side, LED connected to pin 13 working great. So, next thing to do, going back to pulse width modulation, back to frequency checking. So let us just do that. I'll put the multimeter back to 20 Hertz. Then with the probe I need to find out if this pin 4 is 30 Hertz. Well, it says 60 Hertz, but I doubt that, because I disabled everything that said 60 Hertz. On the other hand, alright, let's go back here for a moment. Alright, now you can see it, I hope. And yeah, this way you can see it better. So 60 Hertz. Now back to this single wire coming from pin 13. 60 Hertz. And earlier on it was just miserable, anything but. And here you see this is working. So let me take a little look why that gives 30 Hertz instead of 60 Hertz instead of 30. And there is absolutely no reason why it shouldn't be why it should be 60. So I'm kind of puzzled with that. Let me just go back to the circuit. Measure here. 40 Hertz, 30 Hertz. This one. 60 Hertz. Or maybe I should just power off and power on. Let me just do that. Okay, pulling the plug to the whole interface. And putting it back in. And then it would be very nice if everything should start to work. Thank you so much. Measuring again. Yeah, right. I don't get this because I'll show you what happens. I powered it on and off. And see what I get. Oh, now it's back to 30. 60 still. 60 Hertz. And how about this one? 60 Hertz. Okay, so that didn't solve it. Anyway, apparently there's a difference in both pulse modulation ways and how the circuit works with it. But I'm more than happy that pins 4 and 13 are back to what they should. Okay, in order to get also this LED working, I'm going to put a jump wire here and let this LED just be in another config, in a slightly different position. So taking this one out, and this should be something like this, and I don't mind everything falling still now. And this jump wire should connect something like this. Oops. Let me check again. Yep, that's the correct direction. But it doesn't, it still doesn't work. Or does it? Let me... No. Everything works except that one. So I need to check it on the power controller. But I'm happy for the current situation. And I'm going to leave it with this for now. So, although, yeah, a little bit of pulse modulation, restoring the old code, restoring the electronics, and getting this one working for the first time. This one has yet to be done. I could put this inductor back to where it comes from, making things nicely. And that's it for now. So, thank you for watching. If you like this video and you haven't subscribed yet, please do so. Also see my Instagram, and if you like my videos, please consider to make a small donation. You can find more info on my website, which is listed in at the start of this video and under this video. And this is certainly going to be continued. So, bye bye.